Question 1. When analyzing a split system operating with R400 TINA, technician Miguel notes a high subcooling of 20 degrees, low suction pressure, and an evaporator coil with partial frost. The superheat measures 5 degrees. He suspects the expansion device is stuck. What is the most likely diagnosis based on this data? A. The evaporator coil is internally dirty, restricting airflow. B. The metering device is restricted or underfeeding refrigerant. C. The compressor valves are leaking back into the suction line. D. The system is overcharged with refrigerant. Answer. Correct answer, B. Explanation. High subcooling, low suction pressure, and low superheat suggest a liquid backup before the metering device, likely due to a restriction. A restricted TXB or orifice limits refrigerant flow, starving the evaporator. Frost formation confirms low pressure at the evaporator inlet. Overcharge would increase both pressures. Refer to EPA section 608, core manual, and ACA refrigeration diagnostic charts. Question 2. As illustrated by NOTU installation, technician Carla observes that when the system calls for cooling, the condenser fan motor hums but does not start. A test reveals proper voltage at the fan motor terminals. What should Carla check next? A. The compressor start capacitor for correct capacitance. B. The fan blade for proper balance and pitch. C. The fan motor run capacitor for failure or degradation. D. The thermostat anticipator setting. Answer. Correct answer, C. Explanation. A humming motor with proper voltage but no rotation often indicates a failed run capacitor. The capacitor helps initiate and maintain rotation. Without it, the motor may draw excessive current, and refer to NEC Article 430 Motors and Manufacturer's Capacitor Testing Guidelines. Question 3. Taking into account an indoor RH of 75% and a dry bulb temperature of 78 degrees, technician Brian suspects poor latent heat removal in residential system. The return airflow is 450 CFM per ton and superheat appears normal. What is the most probable issue affecting dehumidification? A. The evaporator coil is oversized for the load. B. The airflow is too low across the evaporator coil. C. The TSSV bulb is mounted downstream of the coil. D. The indoor blow motor is operating in reverse. Answer. Correct answer, A. Explanation. An oversized coil satisfies sensible load, too quickly shortening runtimes and limiting moisture removal. Despite normal airflow per ton, 450 CFM, an oversized coil leads to short cycles, reducing latent capacity. CAM Manual J and Manual S provide equipment sizing guidelines to avoid this issue. Question 4. With the advent of digital manifold gauges and smart probes, technician Jenna is tasked with performing a full system analysis on a commercial system. Which of the following best practices must she observe to ensure accuracy and safety? A. Only measure pressures at the liquid line using a high side port. B. Keep sensors on for at least 3 hours to allow digital stabilization. C. Verify gauge accuracy against ambient pressure before connection. D. Always connect and disconnect gauges while the system is operating. Answer. Correct answer, C. Explanation. Verifying zero pressure before connection is essential to ensure sensor accuracy. Most digital probes must be tethered to ambient barometric pressure to prevent false readings. Reference ASE's Refrigeration Training Manual. Follow manufacturer's calibration protocols. Question 5. Under the assumption that a technician named Priya is servicing a heat pump in defrost mode, she finds the reversing valve shifting properly, but the auxiliary heat activates despite outdoor temps above 45 degrees. What is the most likely cause? A. The defrost sensor is located downstream of the coil. B. The auxiliary heat lockout setting is improperly programmed. C. The refrigerant charge is too low for defrost operation. D. The reversing valve solenoid is energized continuously. Answer. Correct answer, B. Explanation. Auxiliary heat should be locked out above a set outdoor temperature, usually 4045 degrees. If the lockout is not properly configured in the defrost board or thermostat, it will activate unnecessarily, wasting energy. Refer to RE standard 210 or 140 and OEM thermostat configuration protocols. Question 6. While examining a job site, technician Darnell observes a coworker using a cutting torch near an open refrigerant line. What should Darnell do immediately to comply with EPA and OSHA guidelines? A. Report the behavior to the foreman after completing his task. B. Shut down all tools and request the evacuation of refrigerant. C. Ignore it unless a leak or fire actually occurs. D. Install a recovery machine to mitigate pressure spikes. Answer. Correct answer B. Explanation. Introducing flame near refrigerant risks forming toxic phosgene gas, violating both OSHA 1910 subpart H and EPA 608 requirements. Darnell must immediately halt unsafe procedures and ensure refrigerant is evacuated safely using approved recovery equipment. Safety trumps productivity. Question 7. In response to multiple service calls for code detector activation in a multifamily dwelling, technician Sarah finds that gas furnaces share a common vent with improper slope. Flue gas condenses and backdrafts into units. What must be corrected per code? A. Replace all furnaces with seal combustion models. B. Insulate the vent pipe to prevent ambient cooling. C. Increase slope to a minimum of 1.4 inch per foot toward the vent terminal. D. Relocate the vent termination above the roof peak. Answer. Correct answer C. Explanation. Improper vent slope causes condensation to accumulate and obstruct draft. Per International Mechanical Code in Section 800 1.10, vents must slope upward at equals 1 per foot to maintain natural draft. Co-backdrafting is life-threatening hazard and must be addressed immediately. Question 8. The core principles of shaded pole motors make them suitable for small HVAC applications like fans and blowers. Why are shaded pole motors less efficient compared to other motor types? They operate only with three-phase power. B. They use permanent magnets that increase back emph. C. They have no capacitor and low starting torque. D. Their winding resistance is exceptionally low. Answer. Correct answer C. Explanation. Shaded pole motors lack a start capacitor and produce low starting torque, making them inefficient and suitable only for light loads. Their simplicity and low cost are advantages, but PSC or ECA motors offer greater efficiency. Refer to NEMM MG guidelines for motor classifications. Question 9. Based on the information gathered from a manual J-load calc, a home requires 26,000 BTUV cooling. Technician Ethan selects a 2.5-ton system, 30,000 BTUV. Later, he receives complaints of high humidity. What mistake likely occurred? A. The duct system was undersized for the higher airflow. B. The sensible heat ratio was too high due to oversizing. C. The evaporator coil used was incorrectly matched. D. The system SEER rating was too low. Answer. Correct answer B. Explanation. Oversizing leads to short cycles, reducing runtime for moisture removal. A high sensible heat ratio indicates too much sensible cooling capacity, which degrades latent performance. A CAM manual S requires equipment selection to be equals 15% oversized from the calculated load. Question 10. From a practical standpoint, technician Lily is troubleshooting a rooftop package unit that cools intermittently. She finds normal charge, clean filters, and proper airflow. However, the unit cuts out randomly. What should she test next in a diagnostic process? A. Bypass the thermostat to see if cooling resumes. B. Replace the contactor as a preventive measure. C. Inspect high and low pressure switches for intermittent faults. D. Clean the condenser coil to lower head pressure. Answer. Correct answer C. Explanation. Intermittent cutout with normal pressures during checks may be due to pressure switches opening under transient conditions. Some switches auto-reset after tripping, hiding the root cause. Testing continuity during operation reveals faults. Refer to ANSI Standard 15 for safety control functions. Question 11. To illustrate this point, technician Omar is diagnosing a walk-in freezer that runs continuously but never reaches the desired negative 10 deg. The suction pressure is low, head pressure is normal, and there is no frost on the evaporator. He confirms proper superheat and voltage. What component is most likely causing this issue? A. The compressor valves are worn and bypassing. B. The evaporator fan motor is running in reverse. C. The TSV sensing bulb is detached from the suction line. D. The condenser coil is partially blocked. Answer. Correct answer. A. Explanation. Worn or leaky compressor valves reduce compression efficiency. The system may run continuously without achieving set point due to refrigerant re-expanding into the suction side. Normal head pressure and superheat eliminate charge or airflow issues. Refer to our CESA service procedures and Copeland compressor diagnostics. Question 12. By comparing two identical furnaces in different homes, technician Lee observes that one produces excessive carbon monoxide in the flue gas, despite both showing proper gas pressure and burner flame color. What is the most probable cause? A. The unit is overfiring due to a faulty gas regulator. B. The secondary heat exchanger is partially blocked. C. The blower speed is set too high, reducing flue velocity. D. The combustion air intake is undersized or blocked. Answer. Correct answer. D. Explanation. Inadequate combustion air limits oxygen availability, leading to incomplete combustion and elevated CO levels. This occurs even with correct gas pressure and flame appearance. An FPA 54 requires properly sized combustion air openings. IAC and CO risks make this a critical safety issue. Question 13. The effectiveness of a duct system is evaluated during a system balance. Technician Jeremy records high static pressure but adequate airflow at supply registers. The return side reads 0.35 VA and the supply 0.50, totaling 0.85. At conclusion should Jeremy draw? A. The evaporator coil is clogged with debris. B. The return duct system is undersized or restricted. C. The blower motor is operating at incorrect RPM. D. The filter is too restrictive for the airflow. Answer. Correct answer. B. Explanation. High return static pressure suggests the return ductwork is restrictive or undersized. Total external static 0.85 exceeds typical residential limits 0.5. According to a CAM manual. D. Proper duct sizing is critical to airflow performance and system longevity. Question 14. Through careful analysis of repeated control board failures in a packaged rooftop unit, technician Marcus discovers voltage spikes during compressor startup. Which of the following would best mitigate this issue? A. Install a larger transformer to support startup loads. B. Replace the board with a more robust universal model. C. Add a time delay relay to the compressor circuit. D. Use a surge protector to prevent voltage transients. Answer. Correct answer. D. Explanation. Voltage transients during motor startup can damage sensitive electronic components. Installing a surge protector or line filter prevents these spikes from reaching the board. NEC Article 110.16b covers surge protection for sensitive electronics in HVAC systems. Question 15. The development of modern HVAC controls has led to increased use of thermostats with humidity sensing, Wi-Fi, and smart learning. Technician Nina is troubleshooting a zoning system that doesn't modulate dampers as expected. What should she verify first? A. The damper actuators are all spring return type. B. Each zone sensor has unique address and proper calibration. C. The static pressure control damper is set to bypass at 0.8. B. The system transformer provides 40 per damper actuator. Answer. Correct answer. B. Explanation. Zoning systems rely on sensor identification and calibration to function correctly. Without proper addressing, the controller may misinterpret zone demands. Honeywell and Lennox zoning systems require unique sensor IDs for each zone to avoid conflicts. Refer to zoning control setup guides. Question 16. A critical examination of PA records for a commercial OTU shows recurring compressor trips during peak summer months. Technician Ben inspects the unit and finds dirty condenser coils and high head pressure. What preventive measure should be implemented? A. Add compressor crankcase heaters to each unit. B. Perform coil cleaning at the beginning and mid-season. C. Replace the contactor every summer. D. Install an oversized condenser fan for higher airflow. Answer. Correct answer. B. Explanation. Seasonal cleaning of condenser coils maintains heat rejection efficiency and prevents pressure-related compressor trips. Dust and pollen accumulation are common in rooftop environments. RA&O and PM guidelines recommend at least biannual coil cleaning. Question 17. Among the various refrigerant management procedures, technician Sophia is reclaiming R134 from a medium temp reach and cooler using a recovery machine and DOT-approved cylinder. What must she ensure before transporting the recovered refrigerant? A. Evacuate the cylinder to below 500 microns before reuse. B. Affix proper DOT and refrigerant identification labels. C. Add 10% nitrogen to prevent decomposition. D. Store the cylinder in a horizontal position during transit. Answer. Correct answer. B. Explanation. DOT regulations 40I and CFR require proper labeling of recovered refrigerant containers, including contents and pressure class. Improper labeling may lead to fines or hazardous classification violations. EPA 608 subpart F also requires proper documentation during handling and transport. Question 18. When faced with erratic cooling complaints in a Easton technician Annika notices fluctuating suction pressure and short cycles across multiple indoor units. What is the most likely root cause? A. The main expansion valve is stuck fully open. B. The inverter compressor is operating below minimum frequency. C. One or more indoor units are incorrectly addressed. D. The outdoor fan speed is too low for ambient conditions. Answer. Correct answer. C. Explanation. Incorrect addressing of indoor units confuses the controller's load tracking, causing uneven refrigerant flow and erratic pressures. ERF systems require precise communication mapping between IDIS and ODIS. Refer to OEM startup commissioning protocols. E.g. Daikin Mitsubishi Electric. Question 19. The correlation between equipment selection and local energy codes becomes critical when installing new systems. Technician Lewis replaces a 12-SEER split system with a 14-SEER heat pump in a southern U.S. climate zone. What else must Lewis verify for full code compliance? A. The disconnect box is no more than 10 feet from the condenser. B. The airflow is at least 500 CFM per ton of cooling. C. The outdoor unit is installed on a hurricane-rated pad. D. The indoor evaporator coil is RO matched to the new condenser. Answer. Correct answer. D. Explanation. RO matched indoor and outdoor components ensure SEER ratings and performance standards are met. Mismatched coils can result in non-compliance with local energy codes and void manufacturer warranties. Reference RE directory and IG requirements. Question 20. Focusing specifically on a 24th control circuit, technician Raymond finds that the compressor and fan operate independently but never simultaneously. Reviewing the schematic, he sees an SPT relay controlling both loads. What wiring issue might explain this behavior? A. The relay's common terminal is connected to Y instead of R. B. The thermostat is programmed for dual-stage cooling. C. The normally closed terminal is energizing the compressor. D. The 24th transformer is overloaded, reducing current flow. Answer. Correct answer. A. Explanation. A miswired relay common terminal can reverse logic, energizing one load while disabling the other. Proper use of SET relays requires precise wiring per schematic. NEC Article 725 applies to Class II circuits, and control logic errors are common in field wiring. Question 21. Considering the evidence, technician Marlon installs a new smart thermostat on a dual-fuel system with an electric heat pump and a gas furnace. During cold weather testing, he finds that both systems run simultaneously, raising safety concerns. What did Marlon most likely overlook during installation? A. Enabling the balance point to prevent concurrent heating. B. Configuring op-terminal polarity for reversing valve. C. Installing a bypass humidifier between the systems. D. Adding a dedicated transformer for auxiliary heat. Answer. Correct answer. A. Explanation. Dual fuel systems require an outdoor temperature balance point to disable electric heating when gas heating is active, avoiding simultaneous operation. Without it, both systems may run concurrently, wasting energy and violating efficiency logic. Refer to thermostat setup guides and ASHRAE 90.1 for energy compliance. Question 22. Upon closer examination of an air conditioning system, technicians Arena measures correct voltages, steady airflow, and normal static pressure. However, the evaporator temperature drops below 30°, and the coil begins freezing. What hidden issue could be causing this? A. The refrigerant charge is slightly low. B. The return duct has multiple sharp elbows. C. The blower motor is ramping too slowly in echo mode. D. The TXB is oversized and remains wide open. Answer. Correct answer. A. Explanation. A slightly low charge reduces refrigerant mass flow, lowering coil pressure and temperature potentially below freezing. This condition can exist despite normal superheat and airflow. System performance analysis is essential in borderline cases. Refer to co-refrigerant diagnostics and EPA 608 section Roman. Question 23. In terms of motor behavior, technician Isaiah replaces a failed condenser fan motor with one rated at the same horsepower and voltage, but the motor overheats within minutes. What is the most probable cause? A. The fan blade is undersized for the new motor. B. The replacement motor has a higher flow rating. C. The rotation direction is opposite to airflow. D. The capacitor is undersized or mismatched. Answer. Correct answer. D. Explanation. Using a mismatched or undersized capacitor causes poor motor torque and higher current draw, leading to overheating. Even if HP and voltage match, motor and capacitor specs must align. Refer to NEMA MG and motor manufacturer data for capacitor sizing. Question 24. Through the lens of thermodynamics, technician Ali insulates a refrigerant line with a vapor barrier. Later, she observes condensation forming around the pipe joints. What caused the condensation issue? A. The pipe insulation is too thick and traps latent heat. B. The vapor barrier is broken or improperly sealed. C. The refrigerant is subcooled too much by the condenser. D. The pipe is installed too close to a hot air duct. Answer. Correct answer. B. Explanation. Moisture from the air condenses when it contacts cold surfaces. A break in the vapor barrier allows humid air to reach the cold pipe, forming condensation. Atom C outlines requirements for sealing insulation vapor barriers to avoid condensation. Question 25. The central argument for technician Devon's diagnosis is split system with low suction pressure, high superheat, and near-zero subcooling. What condition does this indicate? A. The TSV sensing bulb is sensing superheated discharge gas. B. The system is critically undercharged with refrigerant. C. The compressor windings are open and not pumping. D. The condenser fan is operating below rated speed. Answer. Correct answer. B. Explanation. Low suction, high superheat, and no subcooling indicate insufficient refrigerant. The evaporator is starved, leading to inadequate cooling and overheating of vapor. This classic undercharge profile is well documented in EPA 608 top Roman refrigerant diagnostics. Question 26. Historically speaking, technician Valerie completes multiple service calls each day. She uses shorthand notes and voice memos but often fails to document refrigerant use, pressure readings, and equipment status. What key risk does this pose? A. Inability to collect customer payment after warranty repairs. B. Violation of EPA Section 608 record-keeping rules. C. Increased liability from misfiled invoices. D. Inefficiency in part ordering and delivery. Answer. Correct answer. B. Explanation. EPA Section 608 mandates documentation of refrigerant recovery, leak rates, and servicing data, especially on systems over 50 pounds. Inadequate records can lead to fines or enforcement action. Accurate documentation also supports warranty and legal defense. Question 27. From multiple perspectives, a 5-ton rooftop unit repeatedly blows its 24 fuse. Technician Ron traces the issue to a contactor coil that is slightly melted but still pulling in. What should be Ron's next course of action? A. Bypass the contactor coil and jumper the circuit. B. Replace the fuse with a time delay fuse of higher ampacity. C. Replace the contactor immediately. D. Add a start kit to reduce load on the coil. Answer. Correct answer. C. Explanation. A damaged coil draws excessive current and causes nuisance fuse blows. Even if the contactor pulls in, it poses a fire and operational hazard. NEC Article 240 emphasizes fuse protection, and faulty coils are common causes of low-voltage circuit overloads. Question 20. The traditional approach to steam boiler operation includes monotone water cut-off devices. Technician Bernard finds that the burner intermittently shuts off, though pressure and temperature remain stable. What should Bernard investigate first? A. The pH level of the water in the boiler. B. The wiring and operation of the lower. C. The operation of the vent damper motor. D. The expansion tank water level. Answer. Correct answer. B. Explanational devices interrupt burner operation when water level drops or sensors fail. Electrical issues or float switch malfunction can cause false shutoffs. ASM CSR requires regular testing and verification of safety shutoff devices, especially on steam systems. Question 29. The growing trend in modern home design includes tight building envelopes and compact duct runs. Technician Celeste installs a new supply trunk with two 9-tided elbows. The homeowner later complains of weak airflow. What design principle was likely overlooked? A. Use of R8 duct insulation in humid climates. B. Minimizing turns and transitions to preserve static pressure. C. Avoiding flex duct within 5 feet of air handler. D. Matching airflow CFM to C. A rating of condenser. Answer. Correct answer. B. Explanation. Excessive turns increase friction and static pressure loss, reducing airflow to terminals. The CAM manual D recommends minimizing elbows and sharp transitions. Each 9-tided elbow can add the equivalent of several feet of duct run in pressure loss calculations. Question 30. Examining the consequences of poor PP usage, technician then performs brazing without eye protection and sustains minor burns. OSHA later audits the site. Which OSHA regulation addresses this violation? A. 29 CFR 1910.134 respiratory protection. B. 29 CFR 1926.403 electrical safety. C. 29 CFR 1910.132 general EPE requirements. D. 29 CFR 1910.1200 hazard communication. Answer. Correct answer. C. Explanation. 29 CFR 1910.132 mandates proper PPE for hazards including heat, chemical exposure, and flying particles. Iron hand protection during brazing is essential. Failure to enforce PPE can lead to fines and safety violations during audits.